Now, second idea is involving dimerization via hydrogen bond. Now, this is also fairly easy, a classic. My carboxylic acid can form hydrogen bond with another carboxylic acid under certain conditions. So what it can do is it can form hydrogen bond with each other, and then it will pair up, or we say that it forms a dimer. How do we draw this guy? It's also quite easy. We just show out the bonds for your acid group, and we draw an inverse of your acid to the other side. So you notice this acid on the left hand side, C double bond O group is on top, the OH group is at the bottom. The partner, we will flip this around, the double bond O group is at the bottom, the OH group is on top, correct? So now it forms like an inverse of each other. When we label the species, oxygen is more electronegative than carbon and hydrogen. So oxygen will be all the delta minus charge, carbon will be all the delta positive charge. So oxygen is a minus, carbon is a plus, O is a minus, hydrogen is a plus. Oxygen minus, carbon plus, oxygen minus, hydrogen is a plus. Then the hydrogen bond will be between your negative oxygen and your positive hydrogen. So this will be a hydrogen bond. I have another hydrogen bond here. So forming this dimer, I don't think is that much of a problem. It's also quite easy for me to draw. So let's use exercise 7 to try to reinforce this idea. In gaseous state, the MR of ethanoic acid is found to be 120 instead of the usual 60. So obviously it doubles. So it makes it very obvious. I know that it forms a dimer. And what we will do is we will just explain, okay, this guy can form a dimer via hydrogen bond. So therefore the apparent MR will double. Then we just draw this dimer out. In my opinion, I think the dimer is pretty simple. And usually questions, when they ask us or when they want to test us on this idea involving dimerization, they are pretty nice. They just make it obvious that the apparent MR is double. So it's very, very easy. I think what is interesting that we want to take note of is when the question asks us to explain this observation, what we are doing is we are just showing how the MR doubles. The MR doubles when this guy forms a dimer. So whatever molar mass we have, the final molar mass will just be double the original molar mass. We're showing how this is done by forming a dimer, but we actually never really explained why this is the case. You notice previously when we talk about the dimerization of aluminum chloride, is because aluminum is electron deficient. It wants to be stable. Then involving NO2, it wants to form a dimer because again, nitrogen has an odd number of electrons. It is electron deficient, desperate for one electron, it wants to be stable. So involving acids, in the gaseous state, why would it want to form a dimer? It's also linked to stability. But when we answer this, you notice we do not really need to talk about it. But eventually we will discuss this when we do the practice question. Because what we do in terms of explanation, you notice we are just saying what is happening to explain the outcome. But we never really explain why would ethanoic acid want to form this dimer in the first place. So what is the driving force for this dimerization process? Usually the idea doesn't really come out, so eventually we will talk about it. And when we do the practice question, we will try to talk about this. But when we draw the dimer, I think it's pretty okay. Again, you just draw one ethanoic acid, and the inverse of that guy, you form the hydrogen bond between your oxygen and your hydrogen, and the oxygen and the hydrogen of a partner. It's quite easy to show, alright? It's pretty simple. But let us further this discussion, because if we say that, okay, so if it is a monomer, the MR is 60, and if it is a dimer, the MR is like double, 120. So is it like this is the only instance where we will have just MR 60 and MR 120, and there's nothing in between, which is actually not true. It's actually not true, because the process of dimerization, it takes place over a range of conditions. If let's say in this case it is a gaseous state, it will take place over a range of pressure or temperature. It's not instantaneous. Suddenly everybody is dimer, then 100% dimerized, and it becomes MR is 120. Actually, that's not the case. Usually it will take place over a region of conditions, maybe 10% dimerized, then 20% dimerized, and so on. Eventually it becomes 100% dimerized. So during this region where the extent of the dimerization is not 100%, then the apparent MR can be between 60 to 120, any value between 60 to 120. So let me just try to illustrate this using this guy. Effectively, it is the same thing. We're just trying to represent it in a different way. So if I have all these permutations, if I have 100% monomer, no dimer, MR obviously will be the monomer, 60. But on the extreme end, if I have 100% dimer and no monomer, then the MR will be obviously 120. But if it is somewhere in between, if I have majority monomer, a little bit of it is dimerized, then you notice the MR will be greater than 60, but it's closer to 60, maybe like 70, 80, closer to 60. It tells me that, okay, this dimerization is starting to take place, but it's not 100%. Some of it still exists as the monomer. So the apparent MR actually tells me a bit of information in terms of, okay, in this process of dimerization, what is the extent of that dimerization? How much of it has been dimerized? It actually tells me something about the extent of dimerization, correct? So if let's say I have 30% monomer, 70% dimer, it means that the apparent MR is expected to go up, maybe closer to 120, maybe it's like 90 or 100 or 110. It tells me that, okay, it is approaching maximum or 100% dimerization. So based on this MR, we can expect, or we can have some idea involving what is the extent of this dimerization. So please keep this in mind. When you have a question involving, let's say, an acid group, then maybe they tell you that, okay, under a certain condition, the apparent MR, maybe they don't tell you that this apparent MR is 120, because if it is obviously double is a bit too easy, and then we will know that, oh, this is a dimerization process. Sometimes if we encounter, they say that, okay, the MR is 100. So how do we explain that? From 60 to become 100. How do we explain this observation? So what we will do is, first thing we say that, okay, it can undergo dimerization. So you draw the dimer, correct? And it will causes the MR to double. But the apparent MR is not yet 120 because the extent of dimerization is not 100%. That's why we will have a mixture of monomer and dimer. And when we average out this MR, it gives me a MR of 100. So it's just dimerization, but not 100% dimerized. So it will give me the apparent MR, which will be between 60 to 120. All right. So I think this is good to keep in mind, because dimerization questions are pretty straightforward, and it's fairly common for them to give you the MR doubles, but I think it's a bit too easy. Maybe what they can do is they can modify this a bit. They give you this idea, but instead of doubling the MR, they give you maybe an increase to a certain percentage, all right? And then what we do is we just add on to this idea. It undergoes dimerization, yes, but it is not 100% dimerized. So the apparent MR will be closer to double, but it's not yet double,